In this example, it refers to the section opener about being a coach for a girls softball team. So this says, as coach of the Jets, and Jets is the name of the team, as coach of the Jets, you need to figure out the batting order for the 9 girls on the team. How many different ways can you make the batting order? Now, there are 9 girls on the team that play for each of the positions on the softball field, and each girl has to bat. If we were to simply assign the girls randomly to the batting order, how many ways can we do that? So since we have 9 girls here, then I have 9 to choose from to be the leadoff batter. After this first girl bats, then I have 8 girls to choose from for the next position, for the next batting position. Of course, then I have 7 for the next position. I have 6 to choose from for the next. Then 5 to choose from, and then 4 to choose from, and then 3, 2, and then of course I have 1 girl to finish off the batting order. And simply using the fundamental counting principle like we have in previous sections, we did that finding out how many different phone numbers there are, or how many different ice cream cones there could be. It's the same way here. The fundamental counting principle says if there's one way to do one thing and there's another way to do another, how many ways can we do them together? Well, we simply multiply. So for the first batter and then the second batter, how many ways can we fill just these 2 positions? Well, that's 72 different ways. 9 times 8 is 72. So how many is there for the entire batting order? Well, according to fundamental counting principle, we just go ahead and multiply. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That comes out to 362,880 different ways we can make the batting order for these 9 girls. That's a lot. But as we apply the fundamental counting principle, notice something. There's a pattern here. And that pattern is that we start out with the number in question. For here it's 9 girls on the team. And then it counts down to 1. 9, 8, 7, 6, 5, 4, 3, 2, 1. So since it has this type of pattern, we have a name for this. That's called a factorial. And the factorial can be noted as n, and then we have this exclamation point. That's noted as n factorial. N for here is 9. I can write this as 9 factorial. And it's kind of like a shorthand. Rather than have to write all this, I could just write it as 9 factorial. What's 9 factorial? Well, that's equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. And what does that come out to be? 362,880.